Please welcome Jon Hare-Winton.
Cool. Am I turned on? Yes, cool. That's a really weird phrase to say in front of a massive group of people. Good start, good start. So hi everyone, I'm Jon Hare-Winton. When I was offered this, I was a software engineer, tools and infrastructure, but I got promoted 2 weeks ago, so now I manage people. As I said, but I said to someone earlier, they're like, oh, what's management like? I go to meetings, I don't write code anymore. But I was a software engineer doing tools and infrastructure at The Guardian. And today I'm going to be talking about synthetic monitoring, which is a thing we started doing a while ago. And all the experiences I'm going to talk about during this talk, we didn't really have a name for it. We didn't really call it synthetic monitoring. We didn't know that was a thing until we'd started doing it. But there you go. So for those of you that don't know about The Guardian, we're one of the largest English-speaking news companies in the world. So for example, yesterday we had about 9 million unique visitors to our website and mobile apps, generating about 35 million page views. And all of our products, pretty much all of our products are built in-house. That's everything from our mobile apps to our front-end website to all the tools that our journalists use to create content. That's almost completely all built in-house by a team of about 160 people. And that thing up there is the Pulitzer Prize we won in 2014 for the Edward Snowden revelations, because that was us. That kind of gives you an idea of the sort of things we do. So yeah, I'm going to talk about synthetic monitoring. First off, the big question, what actually is it? And then hopefully I'm also going to answer the questions of why you'd want to do it in the first place and how you could achieve it. So first up, synthetic monitoring, what is it? Well, it's this. It's creating system or user actions for the purposes of monitoring. So what this means in reality is rather than being reliant on things happening on your system, you make them happen so that you can monitor them. Which sounds like quite a straightforward idea. But why would we want to do this in the first place? So what it comes down to is this question between things being passive and things being active. So what do I mean by this? Well, I mean active monitoring, so you could say synthetic monitoring is active monitoring because it is actively making events happen on your system. It could be generating traffic, it could be creating events, all for the purposes of you being able to see what's going on. Whereas passive monitoring is pretty much all the monitoring we do these days. So to kind of understand why I think there's a gap, why I think there's a problem, I'll go into a bit more detail about what I actually mean by kind of passive monitoring. So a lot of people might have read it already. If they haven't, I've got some links in the slides later to a really good paper by a guy called Rob Buashuk. I'm not sure if people have read that. He was a site reliability engineer at Google, and he wrote a really, really good paper on his philosophy around monitoring and alerting. And he summed kind of all monitoring up as two different things. It can be causal or symptom-based monitoring. And so causal monitoring, so here's a link. These slides will go around later. This is a link to the paper itself. It's really worth reading. Causal monitoring is monitoring for kind of pure system events. So it could be something like, number of HTTP 500 errors or, database errors, something like that. And then symptom-based monitoring is monitoring for effects on users. So quite often, if you've got a metric coming up saying, oh, you've got an alarm flashing saying we're getting this many 500 errors, that might be a problem for users, it might not. Symptom-based monitoring is aiming to kind of plug that gap and say, okay, users are experiencing this problem, and then you can tie that up to a causal metric. And at The Guardian, we kind of really followed this philosophy of kind of aiming for causal and symptom-based monitoring in different degrees, and found it was really, really quite good. But there were times when it was really not helping us that much at all. Because it was all passive. It was all reliant on things happening on the system to actually be able to do something. Like if you can't monitor for 500 errors if there's no traffic. That doesn't help you. So we kind of reached this point of thinking, is the kind of the monitoring we're doing, is it enough? Is it doing all the things we want to do? Because monitoring is to know the status of your systems. And if your monitoring can't deliver that, then it's not very good monitoring. Then we started thinking, can synthetic monitoring plug this gap? We didn't think that because we didn't know synthetic monitoring existed. We started thinking, is there something that could plug this gap? So the times when passive monitoring isn't enough, I'm going to go through a few scenarios and kind of point out where these kind of causal and symptom-based monitoring things, they're not enough. So the first scenario is if you've got a low traffic but highly critical system. So for instance, at The Guardian, we have our front-end website. Like I said, it's getting 9 million users a day. It's getting 30 million page views. Monitoring, like kind of passive monitoring, is going to tell you a lot because there's always stuff going on the system. For that many people to be coming in 24 hours, there's always activity. But then our content management system, where our journalists create all of our news content, there might be 12 concurrent users in there at any one point. Kind of standard monitoring is not going to really tell us anything there because there's just not enough traffic to trigger these events that are going to tell us things. Whereas then another scenario, sorry, I'll go back to that one. But so yeah, if you've got low traffic, if you generate traffic, so you kind of switch this kind of active monitoring of creating system events yourself, you've then got something to monitor. Your monitoring becomes useful again. So the second scenario is quite similar, but it's something that's got a system that's got really fluctuating usage patterns. So for instance, we used to monitor kind of, page views, all that kind of stuff. And so for our main front-end website, you can't really profile normal because our traffic fluctuates all the time. If you look at a lot of our graphs, and you'll see these enormous spikes that look like, oh God, there's loads of problems. It's not, there's a major news event, and that's like our most important time. But then we'd have all these server alarms going off saying something's really, really wrong because your page views have gone crazy and all that kind of thing. Similar things, other places I've worked. I worked at one place where we built software for financial advisors who work 9 to 5, Monday to Friday. Monitoring's really useful then, but if something breaks at 6:30 on Friday night, you're not going to know about it till the next morning because you've had no traffic on your system. Whereas if you're synthetically generating traffic, there's always stuff going in. You're doing it 24 hours a day, 24/7. You're going to start seeing stuff straight away. And then the last one, and this is a bit more tenuous, is highly distributed systems. So where you've got, for instance, The Guardian's publishing flow, which I'm going to talk about in a little bit more detail soon, but we go from our content management system through a series of APIs until we get to our website. There could be something fundamentally wrong with the publishing flow, but because you've got monitoring on each individual tool in each individual place, you might not actually, the signals that something's wrong might not actually be that strong. You might have a few things, oh, that looks a bit unusual on that API, and oh, that page is doing something a bit weird, but you might not get a holistic idea. Whereas if you're synthetically generating traffic and monitoring what that traffic is doing, you can get kind of a more holistic picture. So that's kind of the theory about what synthetic monitoring is and why we'd do it. But how do we do it? And I've gone really fast in that bit. I've had 4 cups of coffee today, so if I'm talking really, really fast, just gesture at me to slow down. But this is kind of the bulk of the talk, really, anyway, and this is where I think it's more interesting, because I'm going to talk about an example of where we actually implemented or stumbled upon this idea of synthetic monitoring at The Guardian. So I'm going to talk about a product that I built with one of our developers that we ended up calling imaginatively production monitoring. And that is the icon for that tool. It is a monitor lizard. We are inventive. And there's a link here as well to a blog post I wrote about it that goes into much more detail. But what it was I was working on the Guardian's editorial tools team at the time. So we build all the tools, all the content management system, a whole suite of tools that enable our journalists to create content and publish it. And like I said earlier, this goes through, when we create a piece of content, it goes through quite a, well, I'm going to show you a diagram that makes it look really, really simple, but quite a complex flow through all our APIs. And apologies, this slide, I should have done a state diagram or something like that. It's terrible. But we have our content management system UI, and then so that's where the user is actually working and creating a piece of content. Then that goes into the API for the content management system. Then that goes down to our main content API that loads of other systems feed into. And then that pushes it onto our front-end website and our mobile apps. And this is this is the most critical thing we do, is publishing content. That's everything we do. But to tell us what was going on with this flow at any particular point, we had this, which was a series of metrics that were, I mean, not much, unless you know the system inside out, a lot of that doesn't really tell you much. And so we had this problem that we'd kind of followed this really rigorous approach to monitoring it. We had all these system alerts everywhere and all that kind of thing. But because we kind of fell into all three of those scenarios that I talked about earlier, so our publishing flow is highly distributed over a number of systems. We had wildly fluctuating usage patterns, so kind of in UK hours, we've got an office, our main headquarters is in London, then there's about 2,000 people in that office. Then we've got a tiny office in Sydney and a tiny office in New York. In their working hours, there's barely any traffic. In UK working hours, there's loads of traffic. So we fell into that kind of scenario. And then kind of in terms of trying to monitor stuff, we didn't have enough users in at any given point to give us accurate reporting. So all that meant was this dashboard would tell us when things were wrong really, really slowly. So our relationship with all our journalists was usually them coming over and saying, publishing's broken, something's wrong. And then we'd look at this and be like, oh, no, it's all fine. And then about 5 minutes later, all this stuff starts going red. That's not good enough. That led to like a really bad relationship with a lot of our users. People didn't trust the tools, just because we weren't recovering quick enough, and we didn't know about things. So what we wanted to do was we wanted to find a way around this, try and solve this problem. So we thought, right, if we're not getting traffic, let's make traffic, let's create things. So we kind of spec'd out, right, what do we actually want to do? Well, we want to be able to simulate system/user actions. We want to do this from a user's perspective. It was no good just having kind of system metrics. We wanted to see, from a user's perspective, as they created a piece of content, what happened as that went through. We wanted to be able to run this continually, 24 hours a day, 7 days a week, all year round. We wanted it to be fast, because that was kind of our main objective. We wanted to know when things were wrong before our users knew things were wrong. And then from all of this stuff, we needed to be able to get feedback and handle it really, really quickly. And so we kind of looked at these, and I mentioned earlier that I came from a test background originally before I got into development, and used to do lots of test automation, stuff like that. And I kind of looked at these requirements and thought, oh, this looks quite familiar. There's actually a way we could implement this quite easily with our old friends, the test frameworks, and particularly our dreaded friend, Selenium WebDriver. I spent quite a few years predominantly writing WebDriver tests, so I have like a kind of like a love-hate relationship with it. And realized we could take a test framework, because a test framework does a lot of the things we wanted to do. It handles, WebDriver for one could create browser interactions. They're browser-based tools that we're wanting to check here. So we could create a piece of content via the WebDriver. Cool, ticks that box. Handling, like getting feedback from kind of these simulation runs. Test frameworks do that. And we could start to tick off a lot of these requirements. We've got a starting point. We haven't got to go from scratch. We're like, right, we could repurpose a testing framework and turn it into a kind of a monitoring tool. So we thought, right, cool, let's go ahead. Oh, there was one more. Sorry, I forgot Haskell. At this point, I have to apologize. So we're talking about like doing simulated user actions on a system, but because we were using a test framework, I completely interchangeably use the term simulation and tests. No matter how many times I practice this talk, I can't stop doing it. So if I say test, I mean a simulation. If I say simulation, I mean a test. Because we were essentially going to build a load of tests and turn it into a monitoring tool. So yeah, that's my apology. And as ever, if I'm talking too fast again, blame the coffee. So we started with this start point of, right, let's take a test framework. So we at The Guardian predominantly work in Scala. Anyone use Scala? Woo! Like 2 people. Scala's great, but come and talk to me afterwards if you want to talk about Scala. Scala's got a really good testing framework called Scala Test. Has a really nice WebDriver implementation as well. We could use that, but we were going to have to build out on it a bit. So we'd got this start point of, right, Scala Test. What do we do from here to turn it into a monitoring tool? So first thing was we were going to have to expand that test framework, because test frameworks are kind of built with continuous integration in mind, regression testing, all that kind of thing. They're not really No one's really building them for monitoring, and particularly for continual running. So if you think about it, most test frameworks, they're triggered by a command line instruction, and then you kind of build that into your CI pipeline. They don't really have awareness of previous test runs and when they should trigger themselves again and all that kind of stuff. So we had to build that out. So Scala test is really good for this, actually, because it kind of has all these modular test runners, and you can that give you different ways of testing, and you can kind of configure them, and you can add your own. So we built one out, a new one that would allow us to kind of continually run, and the tests would have awareness of the tests that have gone before and when they need to do another one. And that kind of stuff, getting a test runner that could just run continually 24 hours a day in an intelligent way, not just like a cron job triggering tests over and over and over. It was aware of other test runs. That was quite easy. That was pretty quick. We were able to do that in a couple of days. And then we started running these tests / simulations, and then we kind of hit into the thing of we were going to be testing in our production environments, which, as mentioned earlier, people from test backgrounds, that scares us, unjustifiably or not. But what it meant, we had to start thinking slightly differently about things. So I'm sure you've all seen test environments that have had a load of automated tests running on them for kind of a few weeks or a few months at a time. Even with the best will in the world of tests trying to clean up after themselves and all that kind of thing, the test data on test environments is carnage usually within like a couple of weeks. I think we've probably all seen that. But that's fine, because they're test environments. They're isolated. They're away from our users. No one's going to see it. And then we start doing it on production. That's a bit scarier. So we started thinking, right, okay, so because what we were going to do, we were going to have a user create a piece of real Guardian content and publish it onto our website, and then check that it had gone through properly. That was really quite scary, particularly for our editorial staff. They were kind of looking at this and thinking, this is madness. So we had to build in some kind of testability to our system to make sure we could actually do this. We could publish real stuff, but keep it completely hidden from users. And this is the kind of thing that we're used to we're building testability into our products, building kind of hidden things, because that became the rule. Keep it secret, keep it safe. We love our Lord of the Rings references. The whole thing about it became keep the test data hidden. You don't want to leave any evidence of testing. So what we did, we ended up just having a few tags that we could put on the piece of content. And if it had that content, you couldn't access it anywhere outside the Guardian. You could see it if you're at HQ, but you couldn't see it anywhere else. And then we also kind of remembered all those examples of people accidentally pushing kind of fake test data out to production, stuff like that. We realized it had to be honest about itself, because our initial idea was, oh, right, we're creating a piece of news content. It should look like a real piece of news content. And then the sort of the fake news alarm went off in the back of my head saying, what if something goes wrong with our mechanism for hiding content and someone does find this in production? We can't publish a fake news article. So what we did is actually, so we have all these filters to make sure that people don't see the content created by the synthetic monitoring system, but if they do, it openly declares what it is. It says, hey, I'm a test. I exist for this reason, and explains itself. So that for the 2 seconds that one of these pieces of test content is in production, if somehow someone sees it, it's not going to do any damage. So we had to build that in. So we'd taken this test framework, we'd expanded how it could run, we'd made it so our production services could kind of tolerate tests being run on them in production, or simulations being run on them, sorry. And so we kept going. And then we came across some more challenges. So the first one was, and this is kind of as soon as I said WebDriver and loads of people started shaking their heads, it's because of this. Making UI tests reliable is really hard. Particularly when you're going to be running them. I mean, I'll get into how many times we're running them in a little bit. But kind of UI interactions, UI automation, it's like a dumb proxy. It doesn't know what's going on really with your web page. It's just kind of seeing snapshots of it at any given point. So we had to kind of adopt all the best practices. So kind of back in the old days when I was writing automated browser tests, and it was horrible. You kind of knew what stuff you could skip through really, really quickly in your page. And then you knew where you had to have your conditional waits for waiting for things to happen. But we were going to be running these so much, so often, so many times a day that we realized, right, we've got to do best practices the whole way through. So it was kind of reading up again on all like the UI automation best practices and making every test step conditional on the last one completing, all that kind of stuff. That was a challenge to overcome, and one I never thought I'd have to overcome again, but we did. And then there was the issue that they're potentially quite slow. And one of the main requirements I said about was that it's got to be fast. And some of our testers at the time were thinking, oh, great, we're just going to use this tool and run all our regression testing in production. No way. I mean, like, we had this rule on our team that all regression testing had to be able to, if you were merging in some code, in the time it takes to go up and make a cup of coffee and come back again, the test should have finished. So that kind of gives you about a 5-minute window, depending on how you like your coffee. The guy on our team who makes these like 12-minute brewed filter things, he's got slightly more tolerance for testing. But that kind of turnaround, that's not quick enough in a monitoring environment. It's got to be really, really fast. So what this meant was, we built this to do the absolute bare minimum. Like, for us at The Guardian, we create lots of very rich content. So, we've got news articles with embedded everything in them. But that's not the absolute most important thing we need to be able to do. If a major news event happens, we need to be able to publish some text about it. So that's all we did. We create the most simple piece of content we can possibly publish and monitor on that, because that gives us speed. We're not checking all the functionality. The people on our video desk were very annoyed because, for them, video is the most important thing in the world, but we can't be uploading videos for ages. So it's all about speed. It's all about going fast. So we had to bear that in mind. So we started doing this. It's going to work. So quite quickly, we got to this point where we'd got this quite reliable test, reasonably reliable test running. I wasn't going to include this, but one of our developers was like, no, browser automation still excites people. So the computer's doing things on its own. So this is what it does. We got to this point of it creating a piece of content, going through, like I said, it declares what it is, and then it clicks the publish button and follows it through all our APIs, scrapes the HTML of the front-end website, makes sure it's appearing on the mobile apps, and it can do all of that in about, and clean up after itself as well, it can do all of that in about 32 seconds, which is pretty good. So we did that, and we started running it. And so we were finding kind of, even with our tolerance of like gaps between tests, we were running several thousand times a day, 24 hours a day, 7 days a week. And we thought, great, we've cracked it. This is brilliant. We are, all the time, we are creating a piece of content and making sure, and monitoring that the whole way through our stack to make sure that at all times we can publish. We were synthetically monitoring. And then we hit all the other problems. The first one being, because you think, oh, we've built this thing, it's great. Problem solved. It's really not. And this is where it got quite complicated and quite tricky. The first off was that we were running so many of these simulation runs. So if you think about it, in like tests that you build for a continuous integration pipeline, and this is kind of based on some numbers that we had, we were running about 15 tests. Our automated tests would get run about 15 times a day. And they're about 95% accurate. And by accurate, I mean when the tests go green, it means the product is green. It's all good. And when they go red, when they break, it's a problem with the product. It's not a problem with the test itself. And we were getting about 95% accuracy, which is, that's fine, because that's kind of it's like less than 4 incorrect failures a week. And considering the effort to deal with that is, you merge your code in, oh, the test failed, you go and look on the CI box really, really quickly, and you realize it's a problem with the test. You put something into the backlog to fix it. That's kind of proportional, and that's okay that happens a few times. I know all like the test practitioners will tell you that's terrible, but that's reality, like really. And that was fine. But when you start running these things as synthetic monitoring things, so you're doing, say, 3,000 runs a day at 95% accuracy, you've got your monitoring system incorrectly alerting 150 times a day. No one is going to trust that monitoring system, particularly if it's waking up your 24/7 support people at 3 in the morning. They are going to quite quickly request that you turn that off and never spin it up ever again. And luckily, we took probably the best decision we made in the whole build of this thing was not alerting anyone other than ourselves until we were happy with it. So I got woken up at 3 in the morning, no one else did. And it meant we had to go really far into test accuracy. So we started doing stuff like for instance, I said kind of we followed all the WebDriver best practices. Best practice around automated tests is normally you fire up your WebDriver instance when you're about to start running some tests. You run them, then you kill it, and then spin up another one when you need a new one. Turns out actually WebDriver processes, when you kill them, they don't go away that quickly, which when you're running 15 times a day is fine. When you're running 3,000 times a day, they start to build up before they disappear, and they start slowing down the servers that you're running on and things like that. So we had to kind of abandon that and sort of find a way around that problem. Similarly, some of the libraries we were using to generate cookies so we could access our tools, we found they were actually leaving objects kind of lying around, which was, again, slowing down the boxes. So we're kind of getting over 95% accuracy. We were starting to have to go down to like really system-level things and solve those problems. And after much head-scratching and much effort, we got up to about, I think now we run at about 99.85% accuracy. So we get 1 or 2 incorrect failures a day where just, WebDriver does something weird or something just does something that we don't expect. And so we kind of then built in a tolerance kind of level to our test framework. So we went back to the test framework and looked at what it was doing and decided, right, we can't just alert on 1 test failure. So now the test framework has an awareness of the previous 10 test runs. If we get 2 failures in the last 10, then we alert. If we just get 1, it kind of goes into a warning state but doesn't alert anyone. And what that allows us to do, it means we don't miss intermittent problems, but we're not going to alert on something that's just tiny and insignificant. And because it runs so fast, our delay isn't actually that bad. So we got to this really high level of accuracy and tolerance, so the thing was running well, it was alerting when we wanted it to. And then we looked at all the information that it was giving us. So standard test frameworks, made for a CI pipeline. You do your commit or your merge and your test, and then whatever the results of those tests, you want you want loads of visibility about what went on, because whatever the result, it's going to trigger an action. You're going to do something. If the tests fail, you're going to look at the bug they found or fix the test if it's a problem with the tests. If it goes green, if it's all good, you're going to merge something or you're going to release something. They both trigger an action, so you want ultimate visibility. Whereas when you're doing synthetic monitoring, if something breaks, there's a problem in production, panic, we need to know about this really, really fast. Having it turn a dashboard red or produce a test report that you have to dig into and be like, oh, my tests failed, that's not good enough. We need to know really, really fast. So what the system does is instead of generating loads of test reports, it alerts directly to Slack because, if your team's anything like mine, our devs spend more time in Slack than they do in their IDEs, probably. I know I do. And then we alert to our incident tracking system, so we use PagerDuty for that. So we kind of handle it completely it's like first-class alerting. It's not this sort of separate, the test do a thing and then your monitoring does something else. This alerts like monitoring, like proper monitoring. But then on the flip side of that, when one of your 3,000 test runs a day passes, it's your tumbleweed moment. I love tumbleweed GIFs. You don't need to do anything. It's just saying, oh, everything's fine, cool. You don't need to do anything. So what that means is your test framework that's going to kind of produce all these stacks and stacks of reports, you don't need them. Or you don't need to present them in the way that you used to, kind of just having this thing you could dig into on Jenkins or emails everyone on the team. But that data can actually be quite useful as well, but just how you want to see it's a bit different. So we ended up building these screenshots are terrible because it's mostly just text. Front end is not my forte. So we store all the data that we get from the test and we present it in this kind of web page that shows us all the test runs we've done, the status of them, how long it took, and we can drill into them and see a load of metadata around the test. We can see the progress of the test, every single step it's done, get a load of metadata about all the build versions of all the APIs that were running when that run happened, all that kind of thing. And what this allows us to do is when we get a failure, we can dig in really, really fast. And this is where it kind of hooks back up again with that old dashboard of all the system level metrics. Because all those system level metrics that I showed you earlier, they didn't really tell us that much. Whereas with this, if we say on this one, it gets to the point of opening the management tab and it falls over, or it's pushing it to one of the APIs and it fails there, we can immediately say what step in this complicated publishing flow failed, And then our old metrics are far more useful because you go in and say, oh, right, yeah, cool, we're getting 500s on that one, we need to restart it. Or there's database errors, something like that. It makes all this investigation much easier. But again, it's very different to kind of what you want from the reporting from a CI test. So that was it. We built this system. I'm going to have to go really, really fast now. We built this system, and it had some really, really positive outcomes for us, and kind of got us into this. And it was around this point that we'd got it and built it, and I spoke at a meetup about it, and someone said, oh, that's synthetic monitoring. I was like, great, we have a name for this thing. Someone else has already done it. We didn't invent it ourselves. And so, but our outcomes from it, it was faster. So we were starting to beat our users. So now the conversation when something goes wrong, which doesn't happen very often, but when it does, a journalist will come over and say, something's wrong with the tools, and instead of us saying, oh, is there? We can say, yes, we know, and we're rolling out a fix, because we've known about it for 10 minutes, whereas they've only just found it. And that actually really improved our relationship with them, and their trust in the tools is much, much better. Far more accurate. So it used to be kind of our alerts went off. We didn't really know if they were affecting a user that much, whereas we know now if an alert goes off, there is definitely a problem. So we can have this waking people up at 3 in the morning. And it's kind of ended up becoming the sort of the overall main alerting system that The Guardian uses, because like people on our content API team who are kind of downstream from the publishing tools, we know when they've got problems before they do, so they use our monitoring instead. It's quite good. Like I mentioned, diagnosis is much faster. You're not going into a screen of system-level monitoring metrics. You're being told exactly where something's fallen over, and then you can use those metrics much better. And the ultimate seal of approval, all the other teams wanted to try doing it. So for instance, the team that builds our discussion platform, so how users can comment on articles, they create a hidden comment once a minute, 24/7, and are monitoring what goes on with that. That's kind of like the ultimate seal of approval, really, for us. So, yeah, that's kind of our journey to synthetic monitoring. It was really good fun to do as well. So, I would highly recommend it. It really does plug a gap in kind of traditional monitoring when you fall into one of those situations of low traffic but high importance, all that kind of thing. It's definitely worth doing, and using a test framework as your starting point to start creating these system actions is a really, really good place to start. Yeah, are we doing questions or anything, or shall I just say thanks? You can grab me afterwards if you want to kind of discuss anything or anything like that, and kind of share experiences of trying it as well, maybe. So cool, thank you very much.